So, I want to bring to you my experience with polars. And in order to do that, we also have to talk about Pandas, and then there will be a small addition about the DataFrame Consortium. How many of you know Pandas? Polars? I think we don't need this talk. You know everything already. All right, so the idea is that we're going to see from where we started, and why we have Pandas around. So what was the reason behind implementing Pandas? Then we will move into what we like and what we don't like about Pandas. There will be a small introduction about Arrow. We will see what is it. We will move into polars, a small comparison, and then we will talk about standardization. So, just a bit about me. I work as a data scientist. I'm currently located in Hamburg, Germany. My German is very bad. And I also do some other stuff. ChatGPT knows who I am for some reasons. I think I have to talk to OpenAI about this. And yeah, eventually after the conference, we can also talk about guitar and ski, so it's not just about Python, if you're interested. And let's dive into the dawn of Pandas. First of all, Pandas, as I heard from a podcast, Pandas is not a Pokemon name. It stands for Panel Data System. And the reason behind Pandas was that this guy, Wes McKinney, had to implement something, a sort of solution with Python that was meant to somehow mix the power of Excel and what he was doing back then with R. And that was the main reason. So the idea is that Python is very powerful, is very flexible, and what he had in mind was to create something that was somehow meant to handle time series, and it was also meant to exploit Python in some ways. And thanks to him and this small project, now we have Pandas. Basically, as you know, Pandas is based on two main components. The data frame and the series. I think we all know what is it. The data frame is a two-dimension labeled data structure, and behind the data frame we have the series. As you know, behind Pandas there is a lot of NumPy. So Pandas today, it started as a small project, and now we all know what Pandas is. This is very interesting. I like to show this slide because it's very important that we understand that, as many other projects, Pandas started from a very small and not super famous idea, but indeed it was very powerful. And nowadays, Pandas is everywhere. Why I like to show this slide? Because it's important to understand that now we use Pandas a lot. We use Pandas in production. Sometimes I love to have Pandas in production. Sometimes I hate it. And we rely a lot on Pandas today. We have a lot of important packages that are basically based on Pandas. So it's very important to keep this in mind. And one small thing before checking some other concepts we need for the presentation. Last year we had the release of Pandas 2.0. I don't know how much you're into Pandas, but that was a very important kind of update. And I was really looking forward to that. The reason is that there were some small things that I missed with Pandas, and finally we have an implementation of Arrow. We will see what is it. And some other small implementations, some other small features that I was looking for. So keep in mind that for the next slides and for the comparison, we will use Pandas 2.0 against polars. Now, what do we know about Pandas? We say that Pandas is fast. Probably it is. But what do we mean exactly? First of all, we talk about efficient data structure. So we know that Pandas is basically optimized for fast data storage. And indeed, we have a lot of indexing happening under the hood. And this makes everything faster. We can easily read the CSV and then play with it. And we really feel the magic. We really feel that everything is moved. And then is built on top of NumPy, so we can use this C-optimized, C-like functions, which is not really working with C, because indeed, actually under the hood we have Cython, which is a bit different. If you know how compilers work, we're not really compiling code with C, but we have something that is pre-compiled, so it's not as fast as C, but it does the job. And this is one example. We can write something simple with Python, and then we can do the same stuff with Pandas. And as I said, we really feel the magic. We feel that the same operation takes less time and is way faster. But at the same time, we ask ourselves why Pandas is slow. And I think we all agree that sometimes this question pops up. And the reason is that, first of all, memory usage. Every time we load something into the memory, it's very expensive. It requires a lot of memory. And the idea is that it's really difficult to understand how much memory it requires. And I think that probably this is not always bad. I mean, this probably comes from the fact that after the era of big data, this is a buzzword that we don't use anymore. We always talk about LLM. But after big data, what happened is that we started using this package for something that was not probably initially, it wasn't meant for. And now we have this huge data frame in memory, and we have to handle them. And we see that sometimes it's too much. Then we have these suboptimal data types. This is really interesting. This basically means that sometimes Pandas has to automatically invert the data types. What does it mean? It means that you load something into the memory, and Pandas decides for you the type. Some people say that this is, once again, magic, that it works very well, and they like this feature. I call it inconsistencies sometimes. It creates some problem, and sometimes you have to understand which type you have to use for this kind of data, and you need to change it. You need to work with it. You need to understand what's the best type for your data. And another problem is lack of parallelism. So we don't have parallelism in Pandas. We can work with it. We have some packages that can help you to do that. But by default, this is not really implemented in Pandas. So this is an example. I think it's very common. What happens here is that we try to load something. We create the data frame. We try to create the data frame. And the type we get from Pandas in this case is an object. And this makes any operation a bit, like the operations we want to apply to this data frame, a bit slow. And in this cases, what I do is manually changing the data type in order to make everything consistent to what I want to do next. It seems a very simple and not important example, but if you have a lot of data and you're working with a huge data frame, this makes a huge difference. And you have to decide if your data type is categorical, or is an object, or is a string. And based on the packages you're going to use next, this can be a game changer. Now, we need to understand, before moving to Paula's, what Arrow is. How many of you know Arrow? Have you ever heard about it? Okay. At least I can teach you something today. Otherwise, it's for nothing. So Arrow is basically a cross-language platform, and you can see it as a bridge between a lot of applications that have to work with data, not just data frames, but data objects in general. And what we were used to do before was serializing and deserializing data, for instance, saving the data and try to move this data to another application. And this was very expensive. I remember myself playing with different data platforms, and then I had to serialize and deserialize this data in order to make the data available for the next data platform. So this can be very expensive. And the idea is that with this data layer, we don't see that we are moving to another platform, but we have some sort of shared memory. It's really simple to use. This as an example. I'm just like reading some file, and I'm using this data parquet. And under the hood, I'm exploiting error. So most of the times you have error under the hood, but you don't really realize it. Why is this important? Because in Pandas 2.0 now we have an implementation of error, which is not like using arrow, it's another implementation, but that's the idea. And when I try to use PyArrow, usually it doesn't work. Anyways. So now we move to polars. There are some small concepts, about polars, but in the end, what we're interested in is a small comparison. But let's try to understand what polars is. I'm not sure about why it is called polars. I think because polars are somehow stronger than pandas. I think that they wanted to play with this a bit. And RS probably because of Rust. Polars is implemented in Rust. This makes everything faster. People say that Rust is as fast as C. So you can understand that it can be a very huge game changer. Polars, first of all, is based on arrow. So what we have seen before, polars has it almost by default. So it's the core of polars. Another important point is that polars implements parallelism. So you don't have to use anything on top of that, but you have parallelism by default. And having parallelism, it means that if you think about it, if you work in the industry, if you had the chance to work with PySpark, sometimes you don't want to go too far. Sometimes you're working with pandas, and then when something is not working, people say, okay, now it's the time to use PySpark. And you're always like, I don't want to learn PySpark. I feel a bit uncomfortable. This is what I say. I don't know if you feel the same. And sometimes you just need it. You need to use the clusters. And what if I tell you that sometimes it's not really needed, but you just need a good multi-threading package? So sometimes you can use the power of your machine. I consider my new laptop a very powerful machine. I think I can do a lot of things that before I was doing with PySpark. So sometimes you don't have to go too far, and you can just maybe leverage polars. So yeah, parallelism. Now also another feature that I really like is lazy evaluation. That means that compared to eager evaluation, so every time you execute something, you collect the data and you get the final result out of your function, which is usually 42. So the idea is that with this lazy evaluation, what happens is that you execute the code, but you don't collect the result. So you can have some information about the execution, but you don't have to collect all the results from all the functions that you have to run. And as I said, it's implemented in Rust, as fast as C. That's what they say. Now, what does it mean? I mean, I like to specify that there are also some other libraries that somehow are trying to achieve what polars does. In terms of object, in terms of goal. So first of all, polars has his own query engine. This is a different thing compared to pandas. It means that probably they started with the idea of what was not working with pandas, and they tried to improve it. I'm pretty sure that polars is rooted in what we learned about data. I'm pretty sure that what we learned about data, about how we manipulate data, for us, for all the people in this room, we take these things for granted almost. But we did learn a lot of things during the last year, things that we learned thanks to pandas. So things that we had to learn because we had to understand how to manipulate data, how to analyze data. And all these things, I'm pretty sure that polars developers, and we can also ask them, because I know that there are some polars developers at this conference, they were probably rooted in some of these things that we learned about pandas, and they try to implement them into polars. And of course, there are libraries like Dusk that works on top of pandas that can give you some extra features. But once again, it's not the same as using polars, which has parallelism by default. Now let's fight. I want to show you a very small comparison. So this is something very simple. It's something that I tried on my machine. You can also try it as well. Please, if you don't get the same numbers, don't contact me, because you will never get the same numbers. It sounds stupid, but a lot of people contacted me and they say that my slides were wrong. They're probably wrong. So no worries about that. I want to live with this. Okay, so what I did was just like a simple comparison between polars and pandas with operations that I'm used to do. I'm using time, I'm checking the syntax, and I'm using memory, which is a profiling software, which gives you an indication of how much memory you're using. And I'm using this machine. I think it's a powerful MacBook. I'm not really keen into MacBooks, but I think it's quite powerful. And I have this huge data frame. Maybe it's not too huge, but I think it does the job. So first of all, we read the data. We already see that Pandas is, we can say, the winner in this case. The difference is huge. I'm trying to use PyArrow. I'm trying to make it fair. Is this enough to say that it's way faster than Pandas? I think it is, but you can also play with Pandas in this case and maybe try to improve the way we read data. But in the end, we can say that Pandas is way faster. And it also takes less memory, but we can also tweak the memory. We can play with the memory a bit. In terms of syntax, which is very important for me, because when I started using Pandas, when I started implementing things that I have in production with Pandas, I really had to take care of syntax. My team had to understand what I was doing. So every time we use a different packages in Pandas, in Python, it looks like we're working with a new language. So it was really important for me to understand if the syntax was something we were happy with. So for me, syntax is very important. Now, some of the operations I'm used to do: filter, select, and unique. Once again here, Pandas is way faster than Pandas. And in terms of memory, still, I'm not tweaking the memory too much. I can play with that, I can improve it, but Pandas takes less memory in this case. But in terms of performance, you can also try on your machine. Maybe you will get 325, but Pandas, it will be the winner. Pandas, it will be the winner. So the idea here is that when I saw this syntax for the first time, I was a bit unhappy, honestly. As you can see, I put this not super happy face. And the reason is that first, and maybe some people will not agree with me, but when I saw this PL call, which reminds me jQuery, and sometimes it reminds me also PySpark, I wasn't really happy with that because it was an addition to what I knew very well. And we can talk about how Pandas was implemented, how fast Pandas is, but in the end, my team had to copy with this. So it was really important for me to understand if they were happy with the syntax. This PL call, I still dream about it sometimes. I'm not sure if I did like it at the beginning. There would be a twist later, but once again, I didn't really like it. In this case, still, Pandas is way faster than Pandas. What I'm doing here is applying several aggregation functions to the data frame, and I'm trying to do the same with Pandas. Now, I did work a lot with Pandas. I'm not sure if this is the best way to aggregate all these functions, but I wanted to get all good. I wanted to get the same result that I get from Pandas in this case. I think you're really used to this nice way to apply aggregation functions. And this is what I came up with. Maybe there is a better way, I'm not sure. But I can say that this syntax is not exactly what I was hoping for. But anyways, maybe there are better ways to implement this. But this is really important because if you're coming from Pandas, you're really used to what we see on the left. We're really used to aggregating functions in this way, and get a very nice data frame with all these functions, with all these functions as header or as an index. So we're really used to this kind of functions, this kind of syntax. And once again, new column. Here you can see that still Pandas is the winner, but the syntax is not really what I was hoping for. And the problem is that I cannot say that Pandas is bad in this case. I cannot say that the syntax is a bad syntax. It's just not what I was used to. And the idea of using this PL call every time I had to call a column was really annoying at the beginning. But still, in terms of performance, Pandas is still the winner. Now we have this grouping and sort. Once again, something we do very often. What happens here is that the face is smiling quite a lot. And in terms of syntax, Pandas is somehow left behind. The problem here is that when you start using polars and you have to stack all these operations on top of the other, you really see the power of the syntax. You really see that this is meant for doing this kind of things. And you really see that Pandas, in this case, was probably not meant for all these operations on top of the others. This, on the right policy, definitely reminds me PySpark. If you know how PySpark works, you will definitely be happy with the syntax. And even if you don't know polars, you can understand that on the right we have something that is way cleaner and probably easier to understand. So each line is telling you something. And I love that. It actually makes me forget that we have this pl.call. Now, last point. This is an extra, which is API consistencies and types. What happens here? So if you had the chance to work with Pandas in production, you've probably realized that it's really important to work with data types, and sometimes Pandas is a mix of types coming from everywhere, and you need to decide which types you need. Another problem is inconsistencies. Do you know how many things you get from df call, df lock, for instance? You can select a specific item. You can change the data frame. It's too much. Sometimes some people love it. Some people call this magic. They like it. They can copy with it. For me, this is some inconsistency. It depends on how you use it. So summarizing, we can easily say that polars is the winner. We have some problem with the syntax, but we can work with that. Now, moving to the final part of the presentation. Now that we have all these packages and we have so many choices, what is happening in the world of data frames? First of all, we see that we do have we can easily say that polars is the winner, but at the same time, we have a lot of integrations problem. Why don't we switch to Pandas now? Because some packages don't to polars. Some packages don't support polars. ChatGPT doesn't know much about polars. For me, this is very important. I cannot work without ChatGPT. So I'm actually asking myself, when will ChatGPT will be proficient with polars? It's not like this yet, and sometimes there are some issues, but let's see. Maybe it will learn something new. In some cases, I still think, even though you cannot really replace it with Pandas, in some cases, I really think that for instance, ETLs, polars is the best option you have if you can apply it, if you can actually work with that in production. And it advocates for DataFrame standardization. What do I mean? Do you know how many implementation of the min we have? Every package is implementing its own version of the min and some other functions. This is very annoying because if you have to interchange data frames or some other functions across packages, it makes everything very complicated. And now we have different implementation of the min across different packages, and I'm asking myself, why? Why is this happening? I thought that the min was only one. I thought that we had an agreement years ago about this. But apparently, it's not really like that, so we do have some standardization problems. I heard about these DataFrame consortiums. I had a look. They're trying to create standards. I'm not sure how much they will achieve, because some other kind of consortium tried to do the same for some other languages in the past. In this case, I see that making some progress, but apart from this, there are also some other packages, and you will probably heard about this in the next presentation, that are trying to create standards across all these packages you can use to manipulate data. For example, you can use this really nice package to wrap your function, and then you can use your data frame, you can apply to your data frame any kind of operations, no matter if you want to work with Pandas, with polars, or another data frame manipulation package. And I think this is the direction we should go. But once again, we need standardization. To conclude, well, who is going to be the winner? I think we still have 2 kings or 2 queens, whatever. And I don't see polars replacing Pandas in the near future. I'm trying to replace Pandas, the things that I have in production, with Polars. Pretty much all the times. I'm trying to improve my ETLs, and this makes a huge difference. But at the same time, I do have some issues with standardization, with other packages that I have in production. For instance, sometimes scikit-learn still has problem with Polars, or in other cases, sometimes connectors with specific databases are not really implemented with Polars. So yeah. And I hope you like the presentation. I will stay around for questions, easy questions only, and thank you.
Okay, thank you, Alessandro. That was really interesting, really interesting. So we do have a couple of questions on Slido. So the first one is, can Polars beat PySpark? You kind of already answered it.
It depends on what you want to do. If you're working with clusters and with MapReduce, and this is what you need, definitely Polars cannot really beat PySpark. But if you think that the clusters or MapReduce is too much, I think that working with a very well-written multi-threading application it might be enough. It really depends. The question is always like, okay, shall I use Polars instead of Pandas? It depends on how you use it Pandas. If you don't know how to optimize your functions in Pandas, maybe that's what you should start from. So start with optimizing what you have and then understand if you actually need Polars, for instance.
Okay. And the second question is, I'm not sure, maybe someone wants to explain a bit better, because it says, can I use Polars for data analysis? And also from a syntax point of view?
I do. It depends on the packages you want to use. But now a lot of plotting packages are supporting Polars. So the answer is almost yes. But if you're moving from Pandas to Polars, we need to understand what you want to reproduce. But short answer is probably yes.
Okay. We don't have any more questions on Slido. Does someone want to give a live question? Yeah? So can you...
The intelligence integration.
Yeah, please, if you can repeat the question. If you can repeat the question for everyone, I don't know if they heard.
To know if Polars support accessing column directly by the column names instead of doing PL dot
like the same we do with
ABC.
Pandas.
Yeah, but like something that can be read by IntelliSense, so in VS Code, if you do PL dot A, then
you mean
the
integration? Not what I do, and I'm not sure if the IDE. I don't know how much they're compatible. I'm not really sure about this. I would say no, but you know the world is changing so fast.
Did you find something challenging from the switch from Panda to Polar, and how do you handle it?
The challenging part was learning a new package, check the documentation. You don't have, back then, maybe now it's different, but back then I didn't have a lot of examples of the things that I wanted to implement, how to move from something that I had to something that I wanted to have. So that was probably challenging. So learning something new is challenging. And then, of course, for me particularly was the integration with some databases that I was using. So sometimes the connectors, I'm not sure why, but some connectors were missing. So I remember like working with Snowflake, that was an issue. But yeah, so migrating has many challenges. So yeah, I think these two things were probably the most like challenging thing. Yeah.
We do have a couple more questions from Slido. So the first one is, since ChatGPT doesn't help much, Agree. Do you recommend Polar's documentation or other sources to learn Polars?
Polar's documentation is great. You can find all the things that you need, and you see that developers are really into that, and they know what they're doing. So I never had issues with it. And they're also developing very fast. So usually, if you open a ticket, they will probably try to help you. But the documentation is very well done. Yeah.
Great. And last one, since we are out of time, if this standardization project of DataFrame Consortium wins, will it be a huge problem in terms of refactorizing whole codes?
It's very interesting, but let's say that there is a new version of a package and there is a very big change. You will probably heard about this. You will probably hear about this. So it's not that someone will push the changes into your project. First of all, you decide when to update. And hopefully, if you use the version control, nothing will break. But usually, these big changes are well documented, and you will heard about this. It's not that tomorrow the developers will change something drastically just for the sake of standardization. And you can use something on top as well. So you can use some, like what I showed before, on top. So there are like many ways you can like handle this. But I don't think that your project will explode. Yeah. I mean, developers are pushing changes every day. So yeah, no one died.
Okay, we're out of time. So thank you, everybody.
Thank you.